Today, I'm going to talk about the urban digital twin and leveraging that and the 3D geospatial modeling and simulation to infrastructure design and operation. So with that, what I'm trying to do is more on providing some challenges initially, and then after that, going through a number of use cases to elaborate on the different infrastructure types. And for sure, I would like to open the discussion around this topic here. So a quick introduction about myself and my school, School of Modeling, Simulation, and Training. I am an assistant professor at the School of Modeling, Simulation, and Training in the University of Central Florida, located in Orlando, with access to a number of different multidisciplinary areas. And one of my major activities here as an urban planner is more on leveraging the digital twin and geospatial AI for different application areas. And one of the major application areas is infrastructure design and development and operation. So my lab has kind of, conceptual framework in mind. Starting from the middle, we normally look at any problem from the systems engineering, model-based anything, to be able to design and understand what are the behaviors before being implemented. And then we leverage the technologies, specifically the real-time data integration, the real-time data coming from different sources, including the IoT sensor networks, and integrating that with the geospatial artificial intelligence to understand the behavior of the data, the anomalies, and so on and so forth, communicating that through the different immersive technologies like extended reality, and to be able to deliver intelligent urban automation. But at the same time, we consider the sensitivity of data and the cybersecurity aspects. So zero trust architecture is really one of the dimensions that our lab is looking for collaboration across different different groups on this type of topic. So while I'm presenting, I'm admitting as well. So I see some people are coming, so don't worry about the admission as well. So now let me go to the challenges. I believe that all of you agree with me that we are dealing with several challenges here, including the urban heat island, one of the major challenges, as well as the wildfire, natural hazards, as well as cascading challenges over these, including the disease transmission and so on. So these are really challenges that really threaten us in cities and regions and rural areas, but at the same time our infrastructure. So when it comes to the technology, certainly we are dealing with new type of technology coming up, including the quantum computing, the cloud-based edge computing, and so on, all the different type of data capturing aspects, IoT sensors, drones, reality capture, and so on. And then the question is how to harness these capabilities to be able to design and operate the infrastructure. But when we talk about this infrastructure, certainly in urban and regional areas, we are dealing with a very complex type of activities, above ground, underground. So the road networks, the utilities, even the social infrastructure like the hospitals, educational, campuses, and even airports, they are all dealing with several challenges, including the fragmented data or siloed data, isolated analytics, and the ad hoc type of analytics, which really doesn't help us to better understand what are the interrelations across different groups. And also when it comes to the reliability and trust, we always struggle to trust the analytics because of this connectivity. So what we are trying to do here is providing kind of a digital twin framework as a solution. So this book here is a book that we published back in 2024 with the Digital Twin Consortium, in which I am the ambassador for academia and research, and also co-chairing the academia and research working group. And then we try to redefine the digital twin and understanding how these type of emerging technologies can actually address the problem. So the definition is very long. I just want to drag your attention to this part here. So the digital twin is an integration of data-driven virtual representation of real-world entities. So we are talking about the data-driven. That means we are dealing with AI, ML, DL, or deep learning in the virtual representation. So we are not doing any physics-based modeling simulation, which takes a lot of time, because we really want to bring that into a virtual environment and create a bi-directional synchronization interaction between the physical entities and the virtual entities in different levels of frequency and fidelity. So I will elaborate on this a little bit more by providing the use cases, and then further down the road we can talk about this during the discussion. So we have at the Digital Twin Consortium, we have platform stack architecture and capabilities periodical table that I would invite everyone to have a look at this. This is publicly available document and white papers. But one thing I really want to mention here, the elements of digital twin can be summarized in three groups. One is a virtual environment, second is a physical environment, and then third is the synchronization between the virtual and physical environment. So when we have this capability with different level of frequency and fidelity, certainly we might be able to address several challenges in the infrastructure, in urban and regional infrastructure and situational awareness. Another dimension that I want to just set the scene with is the urban digital twin components or standards developed by Open Geospatial Consortium. That we are also a member of this consortium, and we highly support the consortium for different aspects. As you can see here, it covers aspects related to the buildings, through the standards like building information modeling, industry, fire classes, or the CTGA zone standards, underground through the MUDDI or MUDI underground utilities, as well as moving features, and even extracting the position of those moving features with 6 degrees of freedom, which is called geopose, and also sensors of things. So every sensor that is across the cities in different level of altitudes, and these are very important for the design and operation of infrastructure. So I start with the geopose, a project that we have done in collaboration in the digital twin with the Open Geospatial Consortium, where we kind of lead the engineering report as well as integrating the geopose for the camera imagery to be able to geolocalize the objects. And this addresses one of the challenges because if we have advanced type of camera imagery, certainly that comes with the GPS and all the information with the geopose, which is about the X, Y, and Z, as well as other features in the the orientation and so on and so forth in the that feature, that image. But if it is coming from the mobile phone, sometimes is not connected. So the applications are not every application is able to collect all the information. And the trust here for us is to kind of run an automated system for collecting those information from the image and improving the training data model for further analysis, image segmentation, and so on, which is useful for many aspects, including the disaster management, specifically situational awareness through the certain disaster types that you may don't have any advanced type of technology for that. And also certainly understanding what is the condition of the environment around us. Even this could be used by the United Nations mission in Colombia for rural data collection, understanding what is the condition of the road network, so it could be actually really easily adopted in a very low cost type of camera imagery to understand what is the infrastructure performance. And we also use that in our platform in the University of Central Florida for immediate image segmentation. And as you can see, the workflow here is really helping us to run image analysis. So it means that we don't need high-end data collection devices, and with this we are able to understand what is the condition, how to inform the designers of the space immediately for addressing the challenges, and specifically in the case of the emergency. Another dimension is about the application of the building information modeling and IFC, specifically when it comes to the evaluation and compliance. This is a work that I have done with the University of Melbourne in Australia, and currently I'm co-supervising a PhD student in that university, and we were successful to securing a fund from Australian Research Council on a framework for adopting the large language models to move from the 2D paper-based type of building compliance check to the 3D and more large language models. So that as you can see here, the large language model is really helping us to ask some specific questions, very specific, very type of decision-making questions about the wall's location and the distances between the wall and window and so on. And then at the back end, you will see the agent, the different agentic AIs. They work together to be able to deliver the task. And this is again another part of the using the digital twin and also intelligence, AI intelligence into that, so that we can kind of deliver a very hectic and a very complex task in a matter of minutes, rather than actually the human evaluation and error-prone type of activity there. So this is again another indication of how we can kind of use this automation system and generative AI in this area. Another dimension is about the integration of pedestrian and built environment as well as autonomous vehicles. So this is a work that we have been doing with one of our municipalities in our state, city of Altamonte Springs. They deployed the autonomous shuttle bus around a particular area. So we use that geopose integrated with the imagery collected through the autonomous vehicle. And then the idea here is to understand what is the human behavior in different built environment settings. So we collect this type of data so that we can understand how the design of the space, design of the road network, and also even the urban furniture can be improved to avoid any sort of discrepancies with the function of the area. So we want to know whether the form and function are really aligned with each other. And with that, certainly we are adopting AI and deep learning aspects to be able to understand this relation. So as you can see here, in this case, we are dealing with a very complex environment in which the human, the different modes of transport and the design of the space are working together, and there are some issues that might actually lead to the lack of safety and risky behavior. So with that, we actually implemented pose detection capabilities to be able to understand the trajectory of people from the view of the autonomous vehicle, and that will inform whether this behavior of the person is a risky behavior or is a normal behavior, and then how it can be integrated or connected to the built environment in terms of the pedestrian walkway, the design of the space, the existence or lack of the crosswalks, and so on and so forth. There are many aspects involved into this that we are exploring through the adoption of digital twin and artificial intelligence here. So the other case here is a smart airport, metaverse, and digital twin. So airports are very complex entities, and looking at the global airport market and challenges, we see that the market is growing specifically after the COVID and back of the all the aspects related to the hospitality, but we still have the passenger experience problems. We still have issues with the workforce shortages and so on. How we can leverage this, and even aging infrastructure in airports or technology disparities. So just quickly here, we use the aviation communities recommended information systems, or ACRIS, which is specifically provided for airports operation. We connected that with a lot of other type of activities, specifically in smart cities dimension. And this is a collaboration with the Orange County, our colleagues in Orange County Public Works in California, as well as a number of our colleagues. One is in the UK, Rockport software. That's how we can really improve the airport operation. So with that, we provided some conceptual framework, and we try to address issues related to operational outside the airport and inside, including things related to the obstacle limitation surface, the urban traffic impact, and the indoor terminal operations, the weather, and so on and so forth. So with that, we can actually connect the movement of the people inside the indoor area with the aspects related to the outdoor area. So how we can kind of leverage the multi-dimensional platforms for integration, and then understanding the impact of the urban traffic, for example, on the operation in the airport. So this type of activity is very crucial in terms of understanding how we can move forward with a streamlined, integrated platform in a digital twin. So I just want, I'm cautious of time. I just want to conclude and open up the discussion with this and many other aspects related to the underground utilities or aspects related to the flood or natural hazards, the air pollution, and all these aspects. Certainly, there are a lot of new algorithms, new type of activities coming up. But one thing is very important is validation, verification, and uncertainty quantification. So these are very important in any aspect related to this to be able to evaluate and be reliable on the results of the analysis. And also, it's very important to understand the quadrants of the fidelity and frequency and to understand how the computational extensive are our models and our platforms and to what extent they are fit for purpose. So this is very important from the sustainability perspective because in evaluating of the sustainability, and specifically sustainable development goals, we realize that the fidelity challenges are as important of the fragmented data, but how the frequency and the socio-technical aspects can be addressed. So this is very important to be discussed and added to the future development and research agenda. So with that, I come up with the one concluding aspects so that we need to pay more attention to interoperability and standards and different frameworks, specifically use cases that are coming after this. I'm really interested to see how the models, analytics, and the data are interoperable across different domains. How we can validate the outcomes, how we define the validation rules, and how we set the success criteria to be able to ensure the transparency of the results. So these are really important aspects from the socio-technical aspects and the design and operation of the infrastructure. Thank you very much for your attention, and I'm very much looking forward to hear the questions and discussion on this.